Hello everyone. So today we are going to resolve the reticle alignment and the gun alignment issues we had in the project after adding these new weapons. So now, as you can see here, regardless of our position, the character always points the gun into the middle of the reticle. See? So this works for all the gun types we have. Let me try some of them. See, it properly points to the middle of the reticle. Let's try this shotgun. Okay, sorry, that's not a shotgun, that M87. This is the shotgun. Right, okay, so let's see how to fix this issue today. So issue is fixed in this demonstration. Let's see how did I fix it in this episode. And this episode is sponsored by these generous patrons. Thank you very much for your support. Okay, so if I play the game and if I go to the aiming mode, you can see the direction gun pointing and the reticle doesn't match properly. And when I go to the crouch mode, it differs even further. So, and it's common for like all the actually I matched it for the M16 because previously I only had the M16, but now that I have various other guns and the gun holding position, angle, those things are different from gun to gun, so therefore the aims or offsets animations that I have doesn't really match each gun. So I'm going to find a solution for that today. Right, to make it easier for me to fix the issue, let me go to the main gun blueprint, VP gun. Here let's add some visual line that extends from the nozzle of the gun. So let me add a cube here and I'll attach let's call it gun laser. I'll attach it under gun mesh nozzle. Right, and it's huge, so 0.1. Let me unlock this. Oh wait, let me unlock this. This should be, wait, sorry, it shouldn't be under bullet trail, it should be under gun mesh, under nozzle socket. Right, let me make it even further smaller, like 0.2, 0.2, 0.02. Okay, now let's make it longer in this direction and move. Let me make it even longer, 50, let's say. this one I will have to move further. Right. Now make sure that the collisions are disabled for this one, otherwise this will interfere with everything in the game world. And we need to have a clear color. So do we have anything like a red? But let's try this. Okay, that's it. Well, if you don't have one, you can just create a red colored material, and this shouldn't be visible by default. This should be hidden in game. No, I'll make it invisible, and I will make it only visible when I equip the gun. So here, unequip, right here. Let me get a reference to the gun laser and set visibility. As the visibility, I'll use equip. If this weapon is equipped, the laser will be visible, otherwise not visible. Right, now here you can see, if this is correct, the end point of the gun should be in the middle of the reticle, but as you can see clearly, it's not. And if I equip the pistol also, that's the same case. If I switch to the M16, that's fairly okay, but better than the AK definitely, but it's not perfect. Right, now let's add another object here, a spear. To the gun laser, let me make it visible for now. Let's add a spear. This should also needs to be attached on the nozzle. Why is it not visible? What's the scale? Alright, let's make this smaller. 0.1, and I'll move it further along here. Let's say 2000 units. Here also make sure to disable collisions, otherwise that will also interfere. And this also needs to be, visibility should be disabled, enabled only when I equip the weapon. I'll call this one target point. Let me disable the visibility. Now here the spear size is not very large. Right, so that's why it is very small, so we can't clearly see that. me increase the size 0.2, and also let's add the material that same as before, but let's get a black material. We have a hem color. Let me duplicate this. No, let me create from scratch. Hem color unlit. Because I don't need any colors there. Let's create a vector parameter color, and I'll change the blend mode to shading model to unlit, so we can set the emissive color. And if I change the material blend mode to translucent, we will have an option to draw this on top of everything. So even if we aim in front of a wall, we will see this sphere. So depth, disable depth test, enable this. And for the target point, I'll assign hem color unlit. Now see, even if that sphere is behind the wall, I can see it. Even if it is inside the floor, I can see it. Right. Now let's set up a way to, in the runtime, modify the offset values that I have used to drive the same offset. So let me open the character animation blueprint. This is player mannequin, and I have used PPA character new. Here under aiming, here we have a function set aiming rotation. Well, everything here is not used. This is the previous method I used to determine the aiming rotation. So here we have your offset, and we also need to have a pitch offset as well. At the moment we have already roll offset, but actually it is applied as the pitch based on the orientation of the bones. So let me rename this as pitch offset. And where do I set this? Oh, here we have an option to set aiming offset. Let me disconnect it right here and connect like this. Right. Okay. Now let's bind some inputs to dynamically change these offset values that we have used here. If you don't remember where I used them, I use it in here, aim and rotation. I use to drive this aim offset that I have. This is what I use to look around. Right, and if you remember, I have worked so many episodes fixing this aiming direction with various different methods, but still it's not good enough. So here I am working on it again. So here I'm going to use numpad 8 and 2 to move the 𝐴𝐵 offset up and down. So 8, num8, num2, and we can use this set 𝐴𝐵 rotation. No, set 𝐴𝐵 offset. Here, set 𝐴𝐵 offset function to modify this pitch offset and yaw offset in the runtime. Okay. So here in the player character, this is the player character. Let's get the mesh, and in instance we can call set 𝐴𝐵 offset. Let's promote this to a variable. Let's call it 𝐴𝐵 offset. And do we have any default values here? The offset for the pitch offset we have 90. What's the default value? 90. Let me check. Does it actually affect? No. Alright, actually this value is not relevant because I set 𝐴𝐵 offset in here x100, but this doesn't really matter, and is set -30. Right, that's fine. That's fine. Okay, let me collapse this to a macro. Update 𝐴𝐵 offset. Now here what I'm going to do is I need to change the existing 𝐴𝐵 offset. So to do that, let's get the current 𝐴𝐵 offset, and also let's add an input as a rotator. Delta rotator, and we can't add this, so let me split it. No, break the rotator, and let's break this one as well. Oh wait, there is a combine rotate option. Right, I think we can use that. Don't need to have this one. And let's set this as the new 𝐴𝐵 offset. Right, and let's use over here -30. Let's use initially as well. Let's use this 𝐴𝐵 offset as the parameter. Is set -30. I used this added -30 to have some yaw offset in the 𝐴𝐵 direction to match the M16. Okay, now here for 8 and 2 we need to look up and down. We need to adjust the pitch offset here. So this one I'll set to 1. This one I'll set to -1. And shall we check? See, if I press 8, it looks up. If I press 2, it looks down. So now we can have some idea. In order to match that black dot with the middle of the reticle, we have to dynamically adjust it. Right, let me print this value as well, so we can have an idea what kind of an offset we need. And I will use num4 and num6 to adjust the yaw offset as well. Num4, I should move the gun, rotate the gun left. Num6, rotate the gun left means here -1, here +1. Right, now using 2 I can move down, and using 6 I can move to the left, using 8 up, or using 4 I can move to the left, using 6 I can move to the right. So now as you can see here, in this orientation here, P is -8, Y is 27. I think we should keep this printed value for a longer period so that we have enough time to read it. Right, now when I look up, in order to match it, I have to use an offset of pitch -6, yaw -28. But when I look down, it's different. Now the offset has to be pitch -7, yaw -19, and when I look down even further, it's different. It is changing. See? So to ideally match the aiming target with the forward of the gun, we have to make sure this red overlap, not the black dot, red line pierce through the ground exactly where we see the reticle. So now it is aligned, but here we have a different aiming offset, and as we use this turning, as the turning animations are applied, it's also different. So right, so we need some dynamic way to change this offset, because we can't have a fixed yaw offset and pitch offset to match the reticle with the aiming direction of the gun. Right, I think here, if we move the, now if we compare the black dot and the reticle in the screen space, so it is easier that if the black dot is up, we need to move it down. If the black dot is in the left, we need to move it to right. So it would be easier for us to match it, write a dynamic function that dynamically change the aim offset values we have, the yaw offset and pitch offset values. Right, to do that, we need some way to get the location of this black dot. So how do we get it? We have VPI gun interface. Here we have let's add a function get target. What should we call it? Bullet target. And as the output, we need a vector which gives a point in the world space. Let's call it target. And in the gun, as the bullet target, I'll return the location of this bullet target point. Yeah, get the target point, get location, get world location, and return it. Now here in the tick, let's have a branch. And if we are aiming, I think we already have a variable. Yes, if we are aiming, let's adjust this aiming offset. How? Let's get the aiming offset, and also we need a reference to the active weapon. We can use the weapon variable for that. And from this we can get bullet target. Right. Now we can project this world location to the screen space location. Project world location to viewport. World to screen. Right, this one. Player. Let's get player. Oh, actually, this is self. Get player character. Wait, what do we need here? Player controller. Okay, get player controller. Is this true? I think true means if this represents a valid location in the screen space. Okay, so let's have a branch. If true, if it is false, we don't need to do anything. Let me add a reroute node here. Connect here. I think we should collapse this part. Another reroute node. Let me collapse. Oh wait. Let me undo. Select this point as well. So everything will be cleanly collapsed. Adjust aiming offset. Right, so if we have a valid location, we can get the screen position. We can break this. Let's first try the y value. If the y value is larger than, for now let's not make this more complicated. If this is larger than the half of the viewport size, viewport size split divided by 2. If this is the case, here we can call this update aiming offset. here, wait, where is the output? Okay, here let me split this, and let's select the, we are using Y, that means we need to modify pitch here. Let's select pitch based on this value. Pick A. This will become true if the Y value is larger than half of the viewport size. That means if here is the center, it's something below. So then I think we should move this up. That means this should have a minus value. Let's try something like minus 0.2, or if that is not the case, plus 0.2. Right, now let's check. Oh, that's wrong, it's moving up. No, then this should be interchanged. This should be positive, this should be negative. Let's try now. See, okay, now it comes to the center and it vibrates. That's because we haven't considered the case where it equals to the middle. So, but yeah, we are making progress. In the same way, let's decide the X as well. Similarly, if the X value is larger than half of the viewport size, we can select yaw. Based on this, in this case, if X is larger than half of the viewport size, we need to look to right. That means positive, right? Otherwise negative. Or is it? No, that should be interchanged. Right, let's try now. Okay, now it is in the middle. See, the black dot always falls into the middle. There is some vibration, but we will work on that. Now, even if I change the gun, that happens. The same logic works. Cool. Now let's find a way to smooth out this operation. Right, here let's get the difference between, this is Y make it some space. Let's get the difference between this one and the viewport middle and get the absolute value. And let's divide it. Let's divide it by some value like, I don't know, 4. And multiply this value with the result of this value. I think we should let's cram this in between 0 and 1 just to be safe. The reason to do that is so that when we go closer to the middle, the amount that is moved, the dot, will be reduced. And we can use the same logic here as well. Oh wait, I should use the divided value here. Connect to your offset. Right, let's check now. Okay, now the vibration part is gone. Great. And this sudden movement happens because when my character moves with foot, but that's okay because that's realistic. Because as the character turns with the foot, it causes some changes in the aiming direction, but eventually it comes to the aiming location, correct location. Let's try the pistol. That also works no matter where I point. Right, it always comes to the middle. Now the problem is, see, the black dot comes into the place, but when I aim to a closer location, if I shoot, it will hit where we see the black dot, middle of the reticle, but the gun is not actually pointing there because black dot is in a position that is far away, like 2000 units away. So if this is correctly pointing, if the gun is correctly pointing, the red part should pierce the ground in the middle of the reticle. So to fix that, here, when we try to get the bullet target location, we have a function here to get target location. So this one gives us the point if we do a line trace in the middle of the screen, this gives us the point that it will hit the object, whatever the object that blocks in the world space. So we can use this get target location here, get pp character. We have a reference to character, yeah. From the character, get target location, and then we can do a line trace. Line trace by channel. The starting location would be the nozzle location. From the gun mesh, get the gun mesh, get socket location, socket name is nozzle, and the end location is whatever the point targeted by the camera. That's the end location. And if we get a hit here, I'm gonna adjust here the target point as this should be 0. Target point is 2000 units away from the nozzle. So if I get a hit here, let me break this, and we have the distance. I'm gonna set relative location, and here as the x component I'm gonna use this distance. Everything else I'm gonna keep as 0. If you don't have anything hits in the way, I'm gonna do the same thing, but here I'm gonna set x as 2000 units away. So in this way I think I can I can actually point the gun to the point exactly we'll aim through the camera. Is that all? Right after that we need to return this. Let's see now. See? Now the red line always overlaps with the middle. Great. So when we shoot, obviously there are some recoil effect, but that's fine because we need to have recoil. Okay, so I think the problem is fixed. Now I don't think I need the black dot anymore, so let me hide it. Now when we equip, let me break the target point here, so only the red line should be enough. Yeah. Okay, let's try another weapon. See, now that also working properly. When we move it, obviously the aiming sways, but it eventually comes to the middle. There is some problem in the shooting. Oh no, it's fine. Okay, so now we don't need the red line because it is only for testing. Let me check some other animations. How about this one? Oh, it's pointing backward. Oh, wait, let me check. What's wrong here? 𝐂𝐚𝐭𝐫𝐴𝐧. Let me enable the visibility. It's pointing backward. Why? Alright, here nozzle is pointing back. It should be pointing this way. Right, now it should be fine. Let's try. Yeah, it is working. one more issue. So I think this turning animations move the hover body quite fast, so it doesn't have some smoothness. So where do I use them for turning? Alright, here these are those animations. Turn left 90, turn right 90. Here let me select turn 90, turn left, crouching, turn 90, turn 90 left. Let me do a bulk edit here, and the blend option, blend in and blend out time, this is 0.02. let me increase it to 0.1. now we should have some smoothness. We don't need this print now. Let me remove that too. Right, it's better, but if I suddenly turns, this character goes crazy. See, that's not fast enough. But if I press right click here, the character properly turns quickly. So I think I can use the same thing if I turn quickly to the other side as well. Yeah, let me check. So here, if I press right click, what happens is, where I'm aiming, here, when I right click, aim down is called with the true. And let me check, aim down. There is aim down. Right, it's under toggle aim. Okay. Okay, here we wrote. What do? We call this quick aim. Right, quick aim is in the character animation. Let's check quick aim. I just set the aiming. Oh, this is the part. Quick rotate. Here I manually rotate the character quickly to match the aiming direction, and I think we should do that even if I'm still inside the aiming mode, and if I quickly turn the character, quickly turn the aiming direction like this. See, sometimes it goes much slower. Right, so what I have to do is under aiming. So this is done. We are applying this turning animations, but here let's say if this difference, so here what I'm getting is difference of, if this is larger than 45, that means the aiming rotation is larger than 45. That means the forward of the character and the aiming rotation of the character has a difference of 45. So if this one is, let's say, larger than something like 75, let's try 75, then let's call aim down. Let's add a branch here. If this is true, If this is false, let's call this one. If this is true, on the character, let's call a dog with the true. Now let's see. See, now it's better. It always quickly turn where the character needs to look, and it's still footwork is also happening. So yeah, that's good. Let's try crouching. Yeah, crouching is also working. Okay. Alright, so I think we can stop this episode right here. Right, let's check some other weapons as well. How about this machine gun? Right, that is also properly aiming. Let's see the reload. Great, and crouching mode also works. Okay, how about this 𝐻𝐸70? Great. Okay, how about this shotgun? Most work. Great. Alright, everything is fine. And thanks for watching. So as always, project files will be available for the download through the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. Thanks for watching. See you in another episode. Goodbye.